Hi and welcome to the explanation of the problem coins from the programming competition Bergen Open 2021. The synopsis of the problem is that you're playing a game against the famous magician Dr. Zhivago, here represented by the cuttest judge, where you have a starting amount of n coins in a pile. And the game alternates between the player and the Dr. Zhivago taking turns, taking either 1, 2 or 3 coins from the pile. And the loser of the game is the one that has to take the last coin. So in this example interaction I made here, you can see that the game starts with 7 coins, which is represented by n in the input. And the player then takes 2 coins, Zhivago takes 1 coin, the player then takes 3 coins, and since there's only 1 coin left in the pile, Zhivago says that he gives up and the player has won. So there are a few key things we can figure out to help us solve this problem. And the first one is, what is a winning position? So we know that the final case, or the one we want to end up in, is that on Zhivago's turn, here denoted by a Z, we want there to be a single coin left in the pile. That's the state we want to end up in. But we do also know what the 3 states that can take us there are, because we know that the player and Zhivago, for that sense, can only take 1, 2, or 3 coins. They have to take these amounts. So if there are 2, 3, or 4 coins left on the player's turn, here denoted by P, then we're still in a winning position, because we can always make a move that will result in us coming to the winning position. And the funny thing is that we can keep repeating this by figuring out what kind of state does the pile have to be in on Zhivago's turn to allow us to end up in one of these states. And it's the same situation here, that if we can somehow make it that you can take 3, 2, or 1 coin, then we end up in this state, then there has to be 5 coins left in the pile. And this keeps repeating actually, on and on and on and on. So the thing we know is that if we want to win, then we just need the amount of coins to be in the pile on Zhivago's turn has to be a part of this sequence of coins. Because we know that if the amount of coins in the pile is this, then we can keep reducing it to the next number in the sequence when Zhivago's turn, when it reaches to him again. So the question is then, how do we program this? Well, if you take a look at the sequence of numbers, we can notice that n mod 4 will always equal to 1 for one of these numbers, because that's how the sequence is structured and it keeps repeating. So we can use this information to figure out what our answer is going to be, or what our move should be, more specifically. So what happens if we take n mod 4 coins? Well, if there are 2 coins, then we take 2 coins. That's wrong. And if it's 3, we take 3, and that's wrong. And if it's 4, we take none, which is also wrong. But we notice that if we have n mod 0, then we can take 3 coins. So we can say that as a case, if n mod 4 equals to 0, then we can take 3 coins. And then, if we exclude this, then we can take n mod 4 minus 1 coin for the other cases. And the only time this will be incorrect is if we're actually in the losing position in one of these numbers. But we will never be that if we just keep playing optimally. So that would be the else case here. We'll just take n mod 4 minus 1 coin. And if you wrap all of this into a while true loop, and we terminate, we say this is else if instead, and if we terminate when Zhivago says, if the input is I give up, then we have pretty much a functional program that can solve this task. Of course, you have to add in for the starting amount and taking that, but pretty much this is it. Thank you.